Okay, now I want to talk a little bit about pulling everything together and start talking about some management strategies. So this ultimately is the most fun part of the class, where you get to look at some problems and talk about different ways that we're going to manage these fish populations. At least this is the most fun, one of the most fun things for me. So we're going to start with pond management strategies. There's going to be quite a lot of these, because this is where we do there's a lot of problems and a lot of solutions. Then we'll talk about reservoir management strategies, which I don't have quite as much on, although they're of course also very important. So what we want to talk about is uh, kind of look at these things in the order of how the pond ages and evolves. So from building the pond to how to stock it, how to find out what you've got in the pond, then looking at some management strategies for the ponds, and then some common problems and solutions. I'm going to try and break this down into 2 or 3 different sections because there's a lot to talk about here. So starting with just general, there's lots of information out there, and that's of course true about anything now. You can just Google anything. So it doesn't hurt to look. Of course, there's a lot of contradictory information. As always, you're going to try to evaluate the quality of the information you find. Stuff that you find from, say, an extension office is going to be a lot higher quality than your neighbor's crazy ideas across the street. There are over 90,000 ponds in Illinois, and that number kind of startled me at first when I heard about it, but it's more like 92,000. So there's just a tremendous number of ponds out there. That's why pond management is so important, because there's just so many ponds. And for most people, this is where they get the majority of their fishing experience from. They get a lot heavier annual fishing pressure relative to the public lakes. So for example, if you look at ponds in western Illinois, we looked at several of them, I would say 20 or 30 ponds in the 3 counties here around Macomb, and those in aggregate experienced about 244 hours of fishing per acre during a year versus about 154 hours of fishing pressure per acre during that same year in Argyle. And the point here is that this quantifies how much more these water bodies are used than the public resources. And consequently, that's why we need to have good fishing in these private ponds, because they help reduce pressure on public lakes. So one argument that people have is, well, how come the state biologists are out shocking these private ponds, or assisting with these private ponds, or helping to stock these private ponds? Why should we care? They should worry about the public water bodies, let the private people worry about their own. Well, this is why, right? Because if people can't get quality fishing in these private ponds, then they're going to go to the public lakes to look for that. There's going to be a lot more pressure. So this is sort of a way to help spread that angling pressure out. Rule number 1 that I've talked about before, and I continue to stress, there's no substitute for putting energy into the pond every year. Most people want a pond that they only go to a few times a year, that they don't do anything, and they expect to be able to pull out large numbers of quality fish with no effort on their part. And you have to prepare your constituents for the fact that that just doesn't happen. That's not the natural state of ponds. And so if you want a nice pond, just like if you want a nice garden, if you want a nice lawn, you're going to have to put a little bit of work into it. But it's not a tremendous amount of work. It's fun work, and the rewards definitely are tangible. Rule number 2 is that under harvest is usually a bigger problem than over harvest. People just do not, although they fish these ponds hard, in aggregate, individual ponds don't necessarily get fished all that hard, and even when they get fished hard, people usually don't pull that many fish out. And even if they pull a lot of fish out, there's still a lot of fish in there, and these ponds are productive, and they'll replace that biomass. So most of the time your problems are going to be due to overpopulation and under-harvest in these farm ponds. Okay, now when you're building a pond, you need to obviously think about it a little bit. And a lot of times the contractors that have the big backhoes and that build ponds, they're pretty knowledgeable. They're very good at looking at land and deciding where the smartest place to put the dam is. But you want to double check and think about the watershed and what's going to be feeding into that pond. A lot of times people will think about, well, this is where I want to build my house, and so the dam needs to be here, and that's fine, but also think about the watershed. You know, if you can avoid agricultural land, that's going to be the best in the long run, because lots of ag in your watershed tends to predict or tends to cause big problems down the road. But of course around here that's going to be pretty much impossible. You're going to have some ag, if not almost exclusively ag, so you just have to deal with that by planting buffer strips, dry dams, sediment traps, anything you can do to at least slow down that runoff and do something to stop the sediment and nutrients from getting into your pond at such a high rate that that you're going to expect from the agricultural land. Watershed to surface area ratio we're shooting for is about 10 to 20 to 1. So 10 acres of watershed for every acre of pond, up to about 20. That's the butter zone there. If you have less than this, then you're not going to have enough water in the pond. And certainly, this is 2012, I'm recording this, having a big drought this year. Certainly this year, if you had a small watershed, you'd have a good chance of your pond maybe not going dry, but it's going to be very, very low. Too much watershed, and then you can also have problems because you're going to have too much fertilizer coming in. Again, mostly if you've got an ag in your watershed, you're going to have a lot of fertilizer coming in. Too much sediment coming in and too much water coming in. How can I have too much water? Well, if you get a really heavy rain and a big slug and lots of water coming in, and if your overflow might not be able to handle it, you could threaten the dam. Now, having a lot of water coming in certainly is going to help flush out old nutrients and things like that, but usually all that water coming in is bringing in extra nutrients. So 10 to 20 to 1 watershed to surface area ratio. When you're digging the sides, you're looking at about a 3 to 1 slope. So for every 3 meters you go out, the water increases in depth by 1 meter. You don't want to go out 1 meter and down 3 meters. That would be incredibly steep. So 3 to 1 slope is kind of what you're shooting for. What you want is to minimize the amount of water that's less than a meter. If you've got large areas of shallow water, you're going to get lots of vegetation. That's going to be hard to control. It's going to be hard to fish because you've got to fish over it or through it. It's going to be a refuge for small fish. So this 3-1 slope tends to give you the right amount of littoral zone. At the deepest point of the lake, you want a minimum of 3 meters, 9 or 10 feet. So you need that. Now that could potentially act as a refuge in the winter. That if you got that deep water that's not going to freeze, that's an advantage of having the water this deep. Also, if it's this deep, you've got enough water in there that you've got some thermal inertia, so the water temperature doesn't change rapidly. The more volume of water you have, the slower things change and the easier it is to manage. Anything less than an acre, 0.4 hectares, is going to be harder to manage. These really small ponds can change quickly, things can go bad quickly, things can fill up quickly. And that's what a lot of ponds are. They're about that size. So if you can make it at least deeper, sometimes that can provide you with a little bit of a buffer. Here's a diagram of kind of a side view of a pond that's being dug. I'm not sure what this little chunk is at the surface of the water, because this is the water surface, which should be straight across, so I don't understand that. But what they're trying to show you here is this clay core, or a key, they call this when building a dam. This is a important concept of building a dam. This is something that you'll notice that this clay core extends below the water line. And this really helps to stop seepage through the dam. And so that's something to ask about when you're building your pond, and can they build a clay core, and do they know what it is? I can't say that I know everything about the construction or the engineering of this. I know that it's important. You'll also notice that in this diagram they thought ahead and they put some water control structures and some watering structures with pipes going through the dam. Always very useful to have that if you can control the water level. But you'll also notice that they've kind of tried to diagram on these pipes these little collars. These are called anti-seep collars. And it's what it sounds like. It's a collar that goes around the pipe because water is going to try and follow that pipe through the dam. It's going to kind of create a channel for water to fall through the dam, which of course you don't want. But these collars extend out and will stop that seepage along that pipe. Another thing to think about when you're building a pond is to screen the spillway. Clearly you don't want fish to go over the spillway, fish that you paid for to go over the spillway. So something that's much easier to do this when you're building the pond than to do it retroactively. Of course, this is also something that can potentially clog up and cause a problem. So you need to think about different ways to screen the spillway, and you need to be prepared to unclog it in heavy flow. As I said, having some sort of water level control is very, very helpful. I think we mentioned when we were talking about management tools that controlling water level is one of the most important things that you can do. So at a minimum, be able to raise or lower the water level 1 meter. There's several ways of doing this. You can have an external standpipe that you just tip over and the water drains out until it reaches the level of the standpipe. You can have a weir with boards or something that you can pull out one at a time to raise or lower the water. If you can completely drain the pond, that's really helpful, because as we'll talk about, a lot of times the pond just gets so bad you need to call a do-over. And instead of having to go and rope nose the whole thing, if you can just pull the plug and drain it, that makes your life a lot easier. And of course, if you ever need to do any kind of construction or anything, you may want to completely drain the pond. It's a radical move, but it's nice to have that option. I always suggest people think about this when you're clearing brush. You know, you might want to just push that into a big pile for make nice habitat while you're digging the pond. Shoreline vegetation can be very helpful, and you might want to consider planting shoreline vegetation. Of course, it's going to help control erosion. Not only do the roots tend to hold on to soil, but those plants sit there in the littoral zone and absorb wave energy. So imagine that wave coming and hitting a naked shoreline. All the energy from that wave is going to hit those soil particles and dislodge them. But if you've got that vegetation, it's going to absorb some of that wave energy, and that'll also help reduce erosion. Of course, it provides habitat. Aesthetically, there are some beautiful, beautiful shoreline vegetation plants. You know, water lilies, grass pickerel, or excuse me, water pickerel. Grass pickerel would be a fish. Excuse me, pickerel weed. That's what they call it. Okay, yeah. Pickerel weed is a very beautiful aquatic plant. Lots of vegetation that really makes the pond look great. Also, this can act as a trap or a sink for nutrients, especially in the shallow end. So these plants suck up the nutrients before the algae can. That can help with your water quality. Some caveats when you're building a dam: you don't want any trees on or near the dam. Their roots tunnel through the dam and create conduits for water to seep through. And even if you've got the tree and you say, oh, I don't want that tree, and you kill it, well, that root is still in the dam and it will decompose and create a nice channel for water to flow through. Suggestions I've talked about before: if you're building a pond, why not create a few sub-ponds and rear minnows or something in there, and have these sub-ponds connected to the main pond with a large bore pipe and a valve, to where you can just open the valve and drain the sub-pond and let all the forage flush in. A sand beach for swimming. turns out it's also great for bluegill spawning. The bluegill love to build colonies in these sand beaches. And of course, keep your livestock out. A lot of people are building their pond for drinking water for their livestock. If that's true, then you're not going to have a very high quality pond. Not only are the cows going to pee and poop in the water, but just more importantly, them walking around is just going to muddy it up and makes a very unappealing pond. Okay, continuing with developing a new pond, we'd like to briefly talk about stocking the pond. Now, you can think of stocking in two different ways for a farm pond. The initial stocking when you build a pond versus a corrective stocking after you've had the pond for a while. Now, if you look at suggested stocking rates, if you look up, hey, how many fish, Google, how many fish should I stock in my pond? There are as many suggestions as there are people managing ponds, right? They're all over the place. So I'm not going to really tell you too many, like this many bass per acre, this many bluegill per acre, because it varies so much. I did provide you with a handout 18, which was developed here for Illinois. That's usually your best bet, is to look at things that are developed for your area by an extension agent or by the DNR, because they've got years of experience for that area. Basically, in handout 18, it gives you suggestions for how many pounds per acre of different species, and that's also based upon the soil fertility and the expected fertility of the pond. But as you know, again, if you apply anything to such broad areas as a whole state or a whole county, there's lots of variation within that county or that state. And so the best bet is to have a good feel for the productivity of the pond and adjust your rates accordingly. My opinion is it's much more important to worry about the effort after stocking than during stocking, and that directly contradicts a lot of literature, and a lot of people will say, you've got to worry about this, and you've got to stock the pond properly if you want to have a good pond in the future. And I just don't see that. There's just too much variability there. There's too many things that can change, and the experience is that no matter what, you've got all these ponds where people supposedly are trying to stock in a proper way, and they still all go out of balance. So I just think that you need to convince people that, we have a kind of rule of thumb, a general idea, but the most important, of what we should stock initially. The most important thing, though, is what you do every year thereafter. Now, proper initial stocking will give you a better chance at balance. So you can be smart about this. For example, put the forage in the fall, give them a chance to establish, stock the predator the following spring. I know Ken Russell has some variations on this that he likes to try. So certainly there is a procedure that can make this go a little more smoothly. But again, I like to try to de-emphasize how much energy and thought goes into the initial stocking, and put that energy into managing the pond year in and year out. Of course, our most common species that we're going to stock are largemouth bluegills and channel catfish, sometimes red ear sunfish, and that's just because, as we talked about earlier, those combinations seem to provide what the angler wants and to basically play well with each other. Now, corrective stocking is just what it sounds like. You got a problem, you need to do something to fix it. Most commonly in a small pond, that's going to be replacing your channel catfish. As we said, there's not the right habitat, so the channel catfish often don't spawn. If they do spawn, they're very vulnerable to largemouth bass, which are often present in these small ponds. And so you need to stock the channel catfish at a minimum 200 millimeter or 8 inches. And that's the size at which they're not very vulnerable to the largemouth bass. And so if you've got a catfish pond and you've been catching catfish and the catfish have been getting old and dying, you may have to correct that by stocking some. Other specific situations, if you had a fish kill, if you're out of balance, there are times when you're going to need to stock specific fish. Now, where are you going to get them? You can maybe get them from the state of Illinois. I say rarely. I'm not real sure. I'm not real sure if they can still afford to do this. Maybe they still can. I know some of the hatcheries have been closed down. But state of Illinois, at certain times anyway, for a very low fee, we'll provide the proper fish at the proper size for a new pond. Now, once the pond is, they won't supply fish for corrective stocking, as far as I know. Like I said, I'm not real sure if they still do this. Private hatcheries via the Soil Conservation Service or say Farm King during their fish days, that's where a lot of times you can get your fish for corrective stocking, and they're often pretty affordable, and they're certainly in very good shape. Of course, the ones coming from the state are in great shape too. The fish that you want to avoid, of course, bullheads. They're going to muddy up the bottom. They're not going to get big. You don't want them. Green sunfish, never going to get big, reproduce like crazy. Common carp, of course. Buffalo, don't want them. Gizzard shad, whew, they're going to over-reproduce. Never get rid of them. Crappies tend to over-reproduce. Again, maybe there are situations where you can stock a flathead or an extra predator. I've got an uncle who's a crazy fisherman, loves to fish, has a great pond, goes all the time. He stocked crappies, and they're doing great. But he's there every week. He's pulling out fish every week. He can control the water level. He's putting a lot of active management into it. Much more effort than a lot of people will do, and that's why the crappies might be a problem. Walleyes, muskies, striped bass, yeah, those have been investigated. They're possible. They're not always easy to get. They're expensive, and they might, the ponds might get too warm. But they're also kind of low risk, right? The only thing you're going to be out is money. If they go over the spillway, if it gets too hot, if they die, they're not going to spawn. They're not going to wipe your pond out. They're not going to eat all your forage base. So they're kind of low risk, really. If you've got the money, why not? They're kind of fun and might be something special for somebody to catch. Okay, that's first part. That's sort of the building the pond, getting it started. In the next section, I'm going to talk about how to figure out what you've got in your pond, and then if you've got problems, what can you do to solve them.